The wet abrasive blasting standard explained. Standard to determine the level of cleanness and flash rust on steel surfaces after wet abrasive blasting. When is a steel surfaces ready to guarantee a good coating adhesion? The wet abrasive blasting standards help to determine the cleanness, flash rust and surface profile of blasted steel surfaces. They need to be separately specified when preparing a blast cleaned surfaces. The main standard for steel surfaces preparation is ISO 8504-2. This international standard describes different abrasive blast cleaning method for the preparation of steel surfaces. Since vapor blasting is the latest blasting cleaning method, it is not described. However, we can easily extrapolate vapor blasting to the ISO 8504-2, ISO 8501-4 and ISO 8501-1. There are no dedicated ISO standard for determining the visible cleanness of blasted surfaces. The best method is the IP method, which introduces internal standards that combine ISO 8501-1 visual assessment of blasted surfaces and ISO 8501-4 which describe flash rust grades. The best standard describing the cleanliness of wet abrasive blasting are joint NACE and SSPC standards. They cooperate with a separately issued SSPC Visual 5, NACE Visual 9, which describes the flash rust grades. These standards combine elements of existing standards for dry abrasive blast cleaning with elements of the 2012 SSPC NACE water jet cleaning standards. The definition of cleanness for the steel surfaces immediately following wet abrasive blast cleanings are identical to the definition in the 5 dry abrasive blast cleaning standard: SSPC SP5, NACE 1, SSPC SP10, NACE 2, SSPC SP6, NACE 3, SSPC SP7, NACE 4, SSPC SP14, NACE 8. SSPC SP5 for the wet blasting, NACE 1, white metal wet abrasive blast cleaning, SSPC SP10, NACE 2, near white metal wet abrasive blast cleaning, SSPC SP6, NACE 3, commercial wet abrasive blast cleaning, SSPC SP7, NACE 4, brush off wet abrasive blast cleaning, SSPC SP14, NACE 8, industrial wet abrasive blast cleaning. Why assessing the flash rust level is important? The cleanliness level of wet abrasive blastings are identical to those of dry abrasive blasting. However, there is one important difference: the formation of flash rust as a result of wet abrasive blasting. Flash rust forms when the water used for cleaning evaporates and form an oxidation layer on the clean surfaces. Flash rust occurs typically within 30 minutes and color depends on the characteristics of steels and the level of wetness. Note: all coating have the same tolerance for the presence of flash rust. Before applying a protective coating, the contractor must know the maximum permissible level of flash rust on the steel surfaces. Flash rust can be reduced by drying the surfaces after blasting or using the inhibitors. 4 degrees of flash rust. The wet blasting standard defines 4 degrees of flash rust that help to assess how much flash rust has developed. These definitions are based on the extent to which the flash rust obscures the underlying steel substrate, the ease with which it can be removed by the wiping with the cloths, and the amount of material that appears on the cloths after surface is wiped. No flash rust. No rusting is visible with the naked eye. Light flash rust. Small portion of rust, whether evenly distributed or in certain areas, are visible with the naked eye. It is strongly adherent and hard to remove by lightly wiping with a cloth. Moderate flash rust. A rust layer that covers significant part of the carbon surface. It is reasonably adherent and leaves light mark on the cloths when lightly wiped. Heavy flash rust. A heavy rust layer that hides the steel surface entirely. It is not lightly adherent and easy to remove, leaving substantial mass on the cloths when lightly wiped. Surface profile. In the blast cleaning process, grains of abrasives are propelled with a great force and energy at work surfaces. Upon impact, the grains dig into and these rebounds out the surface, leaving the rugged, miniature mountain and valley finish. This surface structure is expressed by the surface profile, which measures the size of shapes created. The surface profile is critical to coating performance as it increases the surface area, provide a key tooth anchor pattern for the coating to adhere to. Vapor blasting uses water and mildly abrasive media to clean metal surfaces without actually wearing away any of the metal, unlike sandblasting, which is a far more destructive process. Water buffers and lubricates the particles on impact, allowing very fine finishes to be produced without damage to the component. The end result is the far finish and no abrasive media is left behind because it's all washed away with the water. To restore components to a like new condition, producing a smooth satin finish. Vapor blasting is also great to surface preparation for bonding, polishing, welding, or coating of parts and components. Cleaning the topography of the surface, this provides an excellent surface for plating. The flushing action of combined water and abrasives allows optimum surface cleanness and preparation for final metal plating, nickel, chrome, brass or silver.
Engine building with vapor blasting. Vapor blasting has become a top priority for many automotive and motorcycle workshops. Why? With vapor blasting, you can clean, restore and protect with one simple steps using wet blasting. With the flow-based topography following nature of wet slurry, you can clean corrosion, oxidization, carbon, rust and years of grease and tarnish out of the tightest places. No other process compares when it's come to not only cleaning but surface finishing parts for the rebuild or partial restoration.